can you solve this geometry challenge? Here's the question. Given this regular hexagon A, B, C, D, E, and F, inside of it, we have point K like this. Now, let's connect this point K to point E, F, A, and B like this. And we created 3 triangles. Here we go. It is also given that the area of this yellow triangle is 14 centimeters squared. And the area of this blue triangle is given as 13 square centimeters. And last, the area of this green triangle is given also as 8 square centimeters. So the question is, what is the area of the entire regular hexagon? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer to this question is 54 square centimeters. Now the question is, how do we get 54 square centimeters? And here is our solution. Alright, to answer this kind of question, what we're going to do is to extend this segment EF and BA like this. Now let's call this intersection as point L. Now, one thing to notice here is this angle right over here is all 60 degrees. Therefore, this triangle LAF is an equilateral triangle, and also this is an equiangular triangle. Now, having said that, we can say also that the length AB is congruent or equal to length LA, and LF to length FE, like this. And also, don't forget that FA is also equivalent to LA and LF, like this. Now, from here, what we're going to do is to connect this point L to point K. And now, let's call this region as X and the other one as Y. So, the area of this triangle LFA is X plus Y. Now, from here, we will use this concept of triangle. So, if we have 2 triangles having the same height, then the ratio of their areas equals the ratio of their bases. Take note that their bases are equal. Therefore, the area of triangle LKA is also the same as the area of the triangle AKB, which is 8 square centimeters. Now, using the same concept, focus on triangle LKE. Take note that the base EF is equal to FL. Therefore, the area of FKL is also 14 square centimeters. Now, from here, let's focus on the quadrilateral FKAL, because the area of this quadrilateral FKAL can be written in 2 different ways. The first one is the sum of x, y, and 13. And also, we can rewrite the area of this quadrilateral FKAL as the sum of 14 and 8. Therefore, we can say that x plus y plus 13 equals 14 plus 8. Now, 14 plus 8, this is just 22. Now, subtract 13 on both sides to get the sum of x and y. And 22 minus 13, this will give us 9. Therefore, the sum of x and y simply equal to 9. Now, take note, x plus y is the area of this triangle LFA. Therefore, we can say that the area of this equilateral triangle simply equal to 9 square centimeters. Now, from here, how are we going to find the area of this regular hexagon? Now, we will use the concept of a regular hexagon. But we will focus on this important property, wherein all regular hexagons can be split into 6 equilateral triangles. Therefore, if we get the area of one of this equilateral triangle, multiply by 6, and that is the area of the regular hexagon. Now, we will use this concept to answer our question. Alright, now let's focus first on our regular hexagon. Now, let's split this regular hexagon into 6 equilateral triangles. Now, from here, take note that we have 7 equilateral triangles. So we have 1, 2, 3, 4, 5, 6, and the last, this one, 7. Therefore, we can say that the area of one of these equilateral triangle is also equal to 9 square centimeters. Therefore, the area of our hexagon, our regular hexagon, simply equal to 6 times 9 square centimeters, or simply equal to 54 square centimeters. And that is our answer to this question. Therefore, given this figure, then the area of our regular hexagon simply equal to 54 square centimeters. And as always, we are done. And of course, let's have some extra challenge. We have 2 extra challenge. So here's the first extra challenge. Given this figure, the goal is to find the area, of course, of our regular hexagon. And here comes the second extra challenge. This is a bit harder than the first. So given this figure, this area represented as x, this is y, this is z. Now, your goal is to show that the area of our regular hexagon is equal to 6 multiplied by the quantity x plus z minus y. And for now, I will wait your answer in the comment section down below. See you on our next video.